So this lesson, we are looking at chapter 1.2 in Pure 2 Maths, year 13, year 2. So this chapter 1.2 about algebraic fractions is quite a short one because it's just an introductory lesson to remind you what algebraic fractions are and to help you to build up the solid foundation work about fractions working forward later in next chapter about partial fractions. So these are nothing you have not done before, but nevertheless, let's have a look. So recap, what I could suggest you to do is you can actually pause the video and have a go through all the question in this notes first for chapter 1.2, and you can come back and look at the answer because I would imagine you have done all of this before. But if you want to go through with me, feel free, but I would also suggest you to pause the video and just go through it on your own for chapter 1.2. Okay. Right, so recap about multiplying and dividing fractions. When we want to multiply and divide fractions, we want to cancel out the factors as much as you can before. So cancel as much as you can before multiplying and dividing. So for example, in here, A over B times C over A, what you can do is the A's can cancel out. So that will leave you with C over B. And for the second one, x plus 1 over 2 times 3 over x squared minus 1, you need to develop the mathematical sense when you see a quadratic, chances are it could be factorized. In this case, x squared minus 1 is the difference of two squares. You can factorize into x plus 1, x minus 1. So I'm going to rewrite this, the whole thing, x plus 1 over 2 times 3 over x plus 1, x minus 1. Now, if we put a bracket in x plus 1, what you realize, these two brackets could be cancelled out. So what we're left with, the final answer will be just 3 over 2 bracket x minus 1. You can expand it or not. It doesn't really matter. Next one, to divide a fraction, you keep the first, flip the second, and change the sign. So a over b, and then flip the fraction, KFC, change the sign. And then a and a can cancel again, so that will leave you with c over b. This one could be factorized. Two things we can factorize in here. I hope you realize. This one and that one. So let's factorize it. So the top one, if I just rewrite x plus 2, x plus 4 as the first fraction, times, so I'm going to do two things in here. One, I'm going to factorize the numerator denominator for second fraction. And two, I'm going to flip it as well as we go. So 3x plus 6 is going to be a new denominator. I can factorize the 3 out. So 3 bracket x plus 2. This one, x squared minus 16 is x plus 4. X minus 4. Now what you then realize is x plus 4 cancel out, x plus 4 cancel out, x plus 2, x plus 2. So my final answer is just x minus 4 over 3. Okay. Your chance to do a bit of practice in here. And when you're ready, you can pause the video now. When you're ready for the answer, you can press play. So the answer in here would be 2 over x minus 3, and this one will be xy over x minus 2. Next, a common mistake students will usually make is that they cross out the y when it shouldn't be. Now, when can you cross out the y? You can only cross out the y when it's a factor on its own. For example, factors mean they have to be multiplied together. For example, if I do 7 times 2 over 7, then a 7 could be cancelled out. However, if you have 7 plus 2 over 7, then you cannot cross out the 7 like this. So that's the difference. Okay, if there's a plus, you can cross it out if it's a factor. Like for example, we did before x plus 2, 3 over x plus 3 times x plus 2 over x plus 2. Now this one we can cancel out because as a whole factor, we can cancel out. Okay, but what you can't do is you can't just cross out a 2, okay, because the whole factor is x plus 2. Right, so right, you will be going to maths jail if you do this. Next, a recap: when you add and subtract fractions, make sure you have the common denominator by cross multiplying. So we'll use this one example number 1 in here, EG1. The common denominator will be x plus 1, x plus 2. So I can make a whole big fraction out of x plus 1. I just want to be a bit smaller. x plus 1, x plus 2. Now for the first fraction, if I want a common denominator to be x plus 1, x plus 2, then I need to multiply the first fraction by x plus 2. So it'll be 3 bracket x plus 2. The second fraction minus 1 times x plus 1. Don't forget a bracket. Reason because if the minus will change the sign inside a bracket. And then we can expand the numerator and simplify it. So it'll be 3x plus 6 minus x minus 1 over. Now, we usually keep the denominator the same. We don't expand the denominator. Reason being is if there's anything we can simplify at the end, we can cross it out. So there's no point really to factorize it unless the question wants you to factorize, expand the denominator, which they rarely do. So just keep the denominator as a factor form like this. Then the top, we can simplify 3x minus x is 2x, plus 6 minus 1 is plus 5. Now, in this case, we can't simplify anything, so we can just leave it like this. Question number 2. Now, question number 2, you do have to realize the denominator, there is a factor, there is a compound factor in here, x squared minus 1. So what you have to do is you do have to factorize it first. So I'm going to rewrite the first fraction, 2 over x plus 1. But for the second fraction, I'm going to write as x plus 1, x minus 1, difference of 2 squares. So let me ask you a question here. What's the common denominator? Now, the common denominator will be x plus 1, x minus 1. Now, you do not have to multiply x plus 1 twice or x plus 1 squared. Like here, the first example, we did x plus 1, x plus 2 for denominator. But in here, we don't have to do x plus 1 times x plus 1 times x minus 1. We don't have to do 2 of them. Well, why? Think of it this way. If you have a fraction, let's say 1 over 2 plus 1 over 4, what will be the common denominator when you want to add them up? Yes, it could be 8, right? It could be 8, 2 times 4, which is 8. But equally, the shortest way, the quickest way is to make both of them out of 4. Because 2 is a factor of 4. So 4 already is the lowest common multiple between 2 and 4. So what I'm trying to say in here is you do not have to multiply them. So let's try that one. So in other words, what we're going to do is we're going to make a big fraction out of x plus 1, x minus 1. Now compare fraction to fraction. In the first fraction, compare denominator, I need an extra x minus 1. So I'm going to multiply the numerator by x minus 1. For the second fraction, you can see the denominator already match up. So I do not have to multiply anything to numerator. So keep it as 4x. So expand bracket, 2x minus 1 minus 4x with minus 2x minus 1 over x plus 1, x minus 1. Minus 2x because, it should be a minus 2 actually. If it's minus 2, then you can factor as minus 2 out, x plus 1 over x plus 1, x minus 1. Actually, it could be factorized. That's why I told you not to expand the denominator. So x plus 1 gone. So the final answer will be minus 2 over x minus 1. Or if you want to get rid of the minus on top, you can multiply top and bottom by minus 1. So it'll be 2 over 1 minus x. Both are equally fine. Right, next page. So practice question, 2 of them. Feel free to use the page and work through it. When you're ready for the answer, you can press play. The first one, I can factorize the denominator for the first one. So 3x plus 5 over, that will be, I believe that will be x minus 4. No, x plus 4, x minus 3. Remember, you don't have to factorize yourself. You can use a calculator. Common denominator for the first one will be x plus 4, x minus 3. So for the first bracket, first fraction, I don't need to multiply anything. But for the second one, I need to multiply by an extra x plus 4. Simplify, you get x plus 5 minus 8 is minus 3 over x plus 4, x minus 3. So what you realize in here is the numerator, we can put a bracket in there for it. cancel it, cancel it. So what does the numerator become? A 1, because when you divide top and bottom by x minus 3, the numerator becomes 1, not 0, so it's 1. So 1 over x plus 4 is the final answer. Second one, similarly, you should get 1 over 3x plus 1 for the second one. All right. And that's the end of 1.2.